Hey everyone, Vinicius here. Welcome back to the channel where we explore the most mind-blowing mysteries of the cosmos. What if I told you that black holes might be more than just cosmic vacuum cleaners? That instead of being dead ends, they could actually be gateways to other dimensions? Could we one day travel through one and discover a parallel universe? Stay until the end to explore the wildest and most realistic theories about black holes as portals to other worlds. And don't forget to subscribe for more mind-blowing space mysteries. Okay, before we dive into the mind-bending possibility of black holes as interdimensional portals, let's start with the basics. What exactly are these cosmic monsters? You see, black holes are regions of space-time where gravity is so ridiculously strong that nothing, not even light, the fastest thing in the universe, can escape their pull. Imagine the entire mass of a star, many times larger than our sun, squeezed into a tiny point. That's the kind of extreme density we're talking about. This point is called the singularity, and it's a place where the laws of physics as we know them completely break down. It's like trying to divide by zero on a cosmic calculator. Things get really weird, really fast. Now, we can't actually see black holes directly because, well, light can't escape them. But we can detect their presence by observing how they interact with matter around them. Imagine a cosmic whirlpool, pulling in everything that gets too close. But here's where things get really interesting. What if black holes aren't just cosmic dead ends? What if, instead of being inescapable traps, they're actually tunnels, gateways to other realities? I know, it sounds like something straight out of science fiction, but the idea has been around for decades, and some physicists believe it might be more than just a figment of our imagination. So buckle up, because we're about to explore some of the most mind-blowing theories about black holes and their potential as portals to other worlds. One of the most popular ideas in both science and science fiction is that black holes might actually be wormholes, tunnels that connect different parts of the universe, or even alternate dimensions. Imagine folding a piece of paper in half and poking a hole through it. That's a simplified way to think about a wormhole. It creates a shortcut through space-time, allowing you to travel vast distances in a much shorter amount of time. This idea, known as the Einstein-Rosen bridge, was first proposed by none other than Albert Einstein himself, along with his colleague Nathan Rosen, back in 1935. They were studying the equations of general relativity, which describes gravity as the curvature of space-time, and realized that black holes could potentially connect to other regions of space-time. Now here's where things get a little tricky. While the mathematics of Einstein's equations allows for the possibility of wormholes, they also suggest that these tunnels would be incredibly unstable and collapse too quickly for anything to travel through them. Think of it like trying to hold open a soap bubble. It's incredibly fragile and pops almost instantly. Similarly, a wormhole would likely collapse faster than the speed of light, making it impossible for even a beam of light to pass through. However, some physicists believe that there might be ways to stabilize a wormhole using something called exotic matter. This hypothetical form of matter would have negative mass and energy density, which sounds completely bizarre, but bear with me. Imagine exotic matter as the scaffolding holding up the walls of the wormhole, preventing it from collapsing in on itself. This would theoretically allow for travel through the wormhole, potentially to other parts of the universe or even other dimensions. Of course, this is all highly speculative, and we've never actually observed exotic matter, let alone a stable wormhole. But the possibility remains an intriguing one, and it continues to fuel the imaginations of scientists and science fiction writers alike. Chapter 3. Black holes and parallel universes. Hold on tight, because we're about to venture even further into the realm of speculation, where black holes might not just be portals to other parts of our universe, but gateways to entirely new universes. One theory that suggests this mind-blowing possibility is based on loop quantum gravity. Now, loop quantum gravity is a very complex theory that attempts to reconcile general relativity with quantum mechanics, but the basic idea is that space and time are not continuous, but rather made up of tiny, indivisible chunks, like pixels on a computer screen. According to this theory, at the singularity of a black hole, where gravity is so intense that it warps the very fabric of space-time, the laws of physics as we know them break down. But instead of a point of infinite density, some physicists believe that the singularity could actually be a bounce, a point where the collapsing matter rebounds and expands, creating a new universe on the other side. Imagine it like this. Our universe is just one bubble in a much larger cosmic foam, and every black hole is like a seed, containing the potential for a new universe to be born. When a black hole forms, it's like planting that seed, and a new universe sprouts from within, completely separate from our own. Another intriguing hypothesis suggests that every black hole in our universe might be connected to a white hole in another universe. Now, white holes are purely theoretical objects that are essentially the opposite of black holes. While nothing can escape a black hole, nothing can enter a white hole. Think of it like this. If a black hole is a cosmic vacuum cleaner, sucking everything in, then a white hole is a cosmic leaf blower, spewing everything out. So, according to this hypothesis, whatever falls into a black hole in our universe might be ejected out of a white hole in another universe, potentially seeding the formation of galaxies, stars, and even planets in that new universe. Of course, these are all just theories, and we have no way of knowing for sure what lies beyond the event horizon of a black hole. But the possibility that these cosmic behemoths could be gateways to other universes is a tantalizing one, and it continues to inspire physicists to explore the boundaries of our understanding of the cosmos. Chapter 4. Could we ever explore a black hole? Okay, so we've explored some pretty wild theories about black holes being portals to other dimensions and even birthplaces of new universes. But let's bring things back down to Earth, or at least try to, and ask a more practical question. Could we ever actually explore a black hole? Well, the short answer is it's complicated. You see, even if we could overcome the immense gravitational pull of a black hole and get close enough to study it, we'd face another major obstacle: spaghettification. Now, spaghettification is a real scientific term, and it's exactly what it sounds like. As you approach a black hole, the gravitational pull on your feet would be significantly stronger than the pull on your head, stretching you out like a piece of spaghetti. This is because gravity obeys an inverse square law, meaning that the closer you are to a massive object, the stronger the gravitational force. So the difference in gravitational pull between your head and your feet would become so extreme that it would literally rip you apart, atom by atom. Not exactly a pleasant way to go, right? But what if we could find a way to protect ourselves from spaghettification? What if we could create a spacecraft strong enough to withstand the immense tidal forces near a black hole? Even then, we'd face another challenge: communication. Remember, nothing, not even light, can escape the event horizon of a black hole. So even if we could send a probe inside, we'd never be able to receive any data back from it. It would be a one-way trip into the unknown. But hey, that's the beauty of science. We're constantly pushing the boundaries of what we know and what we thought was possible. While we might not be able to explore a black hole directly anytime soon, we can still study them from afar, using telescopes and other instruments to unravel their mysteries. And who knows? Maybe one day, we'll develop the technology to overcome these challenges and finally unlock the secrets hidden within these cosmic enigmas. Until then, we can keep exploring the universe with our minds fueled by curiosity and a sense of wonder. So what do you think? Are black holes just cosmic death traps, or could they really be portals to other universes? Will we ever know the truth? If you enjoyed this journey into the heart of black holes, hit that like button and share this video with your friend who loves crazy space theories. And don't forget to subscribe for more mind-blowing explorations of the cosmos. Until next time, keep looking up.